7.2, page 441 in our books. Today's goal is to use the properties of exponents involving quotients. Key vocabulary from last week still exists. It's power, exponent, and base. Our key concept, quotient of powers property. Simply put, to divide powers having the same base, we're going to subtract the exponents. So here's some guided practice to go along with example 1 in your book, again on page 441. Problem 1, we have 6 to the 11th divided by 6 to the 5th. We do have like bases. We are dividing. We're going to keep our base. We're going to use our rule that says we simply subtract our exponents. We end up with 11 minus 5, which is 6. Our final answer, 6 raised to the 6th power. Problem number 2, oops, sorry about that. We have negative 4 to the 9th divided by negative 4 to the 2nd. We do have like bases. We are dividing, so our like base is going to stay. We are going to take our 9 and subtract 2, giving us a final answer of negative 4 raised to the 7th power. We're going to move to the next page here so we can focus on problem number 3. Problem 3 has both multiplication and division. So we have 9 to the 4th times 9 to the 3rd divided by 9 to the 2nd. Using our rules for multiplication with like bases, we're going to add the exponents. 4 plus 3, 9 to the 7th, divided by 9 to the 2nd. Using our rules for quotients, we are going to keep our base and we're going to subtract our exponents, leaving us with the final answer of 9 to the 5th power. Problem number 4 looks a little tricky, but if you write it simply as fractions, here's our first fraction. Y to the 8th, we're going to make it a fraction by putting it over 1. We're going to use the rules for multiplying fractions, which is to multiply straight across. 1 times y to the 8th is y to the 8th. Y to the 5th times 1 is y to the 5th. Quotient rule says we keep our base and we subtract our exponent. We're going to end up with a final answer of y to the 3rd power. Remember last week when we had parentheses, we're taking everything inside those parentheses and raising it to the power. That still applies today. So if you look at 5, these go along with example 2 and 3 in your book on the top of page 443. So 5 says I have a divided by b, and this entire expression is being raised to the 2nd power. A to the 2nd power divided by b to the 2nd power. I have no like bases. There's nothing further I can do, so that's my final answer. Problem 6, I have negative 5 divided by y, all of this raised to the 3rd power. Negative 5 to the 3rd power. Negative 5 times negative 5 is 25. 25 times negative 5 is going to give me negative 125 divided by y to the 3rd power. Again, final answer, no further simplification needed, negative 125 divided by y to the 3rd. Working on a little more room here, we're going to look at problem number 7. We have x squared divided by 4y, all of this being raised to the 2nd power. This power applies to everything inside the parentheses. So x squared raised to the 2nd power becomes x to the 4th. 4 squared and y squared. Getting it into its best form, x to the 4th, 4 squared, 4 times 4, 16 y squared. No like bases, nothing further to simplify, so my final answer, x to the 4th divided by 16 y squared. Number 8, take a look here. We have 2s divided by 3t, all of this raised to the 3rd power, times t to the 5th divided by 16. Let's start by taking this power and applying it to everything inside the parentheses. So we're going to have 2 to the 3rd, s to the 3rd, divided by 3 to the 3rd, t to the 3rd. And we still have to multiply all of this times t to the 5th over 16. Remember, with fractions, we're going to multiply straight across. So 2 to the third, 2 times 2 is 4, times 2 again. So 2 to the third is going to give me 8 s cubed t to the fifth divided by, I have 3 to the third. 3 times 3 is 9. 9 times 3 is going to give me 27 t to the third times 16. So I want to look and see if there's any canceling I can do before I start to multiply. So I'm going to come over here, I'm going to switch to red, and I'm going to do 8 divided by 8 is 1, 16 divided by 8 is 2. And for those of you who don't understand, 8 over 16 in its best form is 1/2. It's easier to cancel than it is to multiply and then reduce. We're going to also look at our t to the fifth divided by t to the third. Like bases, I'm dividing. The rule says to subtract. So if I take 5 and I take away 3, I end up with t squared. So let's go back to black here. I have 1 s cubed t squared. And on the bottom, I still have 2 times 27. 2 times 27 is going to give me 54. So my final answer, s cubed t squared divided by 54.